Okay, so this is a volumetric subtraction version of a surface subtraction. So like I said, just like the house that we looked at, we have things that look like a part that is a volumetric cut as well as a surface cut. Okay? When we did that, of course, we're going to have all these leftover line pieces. And of course, that may or may not be pretty, right? So what we could do is to get rid of those lines. Command for that is merge coplanar faces. I'll show you right here where in the solid tools, there's this object that says merge all coplanar faces, and that would be a right click on the mouse button. If I do that and select this object, notice that there's an extra line right there. Enter, and then that line disappears and kind of heals itself. So that would become a cleaner surface model. Okay. You don't have to do that until the very end. You could also type in merge all coplanar faces, all faces and such. Okay, so there's that. What I want you to do for this exercise is to finish this subtraction. What I want you to do with this thing is that I would like for you to make, actually I would like you to make 2 more pieces out of it. Okay, so if I copy this thing, right? For homework, what I want you to do is to finish this object. Also, I would like for you to make your own version of this surface subtraction object. Okay? That means follow the same step that we've taken to draw the 24 by 24 by 24 box, explode it, take the bottom out, and then offset the surface towards the inside, and then make a few of these cuts. Notice that all of these cuts on the model is straddling a corner. Okay? I want you to follow that, and yes. Also, as homework, there is this thing. 1, complete the cuts for the first box. 2, make your own version of that surface subtraction. But there are going to be a little bit of limits or rules to this thing. One is to employ only straight cuts. No curves, no circles, no squiggly lines. Just use straight cuts. Okay? Use only orthogonal cuts, which means that no angles on this thing. Everything has to be 90 degrees to each other, 90 degrees to the edge of the box. Okay? You don't have to write this down. This is for you. This is, yes. Okay? For the design people in the design class, you're probably doing this by hand as well, right? If you do this on the computer, you can kind of try it out before you invest in cutting the actual model. So that's the positive part about modeling this thing in the computer first. Okay, so you can try it out, see what looks good, and then take the time to cut it out neatly with a knife and all that. Okay. The next one is to complete the demonstration spatial subtraction cube. I know that we probably didn't finish all this right now. I understand. If you did, that's great. That means that you just kept up with it. But what I would like you to do is to make your own version of this thing. That is, again, few rules. Preserve the 4 top corners of the cube. That means that tops right here, 1, 2, 3, 4, don't take any chunks out of that. The good analogy for that is that what Sardinus always uses. If you have an apple and you take a bite of it, do you still recognize it as an apple? Yes. If you take an apple and take more bites out of it, you might like part of the core or something, you might eat that. Will you still recognize it as an apple? No, it's become more like an apple core. That's it, right? So you can't see the original round shape of the apple that it was in. If you take too much of the defining primary solid shape out, then you lose the characteristic of the original volume, which means that the subtraction you made has actually completely changed the shape of your object. Okay, let me demonstrate. If I take this object and do something like that, okay, and then move this right here to there, and then take this out. So Boolean subtract that, take that out, and now it's kind of taken a corner of this thing out. Do you still recognize it as a box? Yeah, it's getting hard to recognize this box because it becomes this L-shaped thing. A little bit maybe, but it would be better if you retain the corner so that you recognize this box as a box. Okay, so what I would like you to do is not this, Control Z, but to just take these corners out. So you want to make about 10 volumetric subtractions, right? We made like 3 volumetric subtraction right there, right? 1, 2, 3. What I would like you to do is to make about 10 of them. And what that'll do is to create on the other side your own volumetric cut as well as a top. The rule is that you probably want to continue or wrap the corner of the cuts around each of the surface. Okay? So when you wrap the corner around each of these, this is what we started with, where we started with that original 6 by 14 by 16 cut, and then the 3 foot by 2 foot cut right there. What I would like you to do is to do similar thing on the other side, and doesn't matter what dimension that you use. However, it should wrap around each of the sides. Okay, that corner it's wrapped around, that corner it's wrapped around. I could also take it to the top. Okay, so this one I kind of made it so that it cuts halfway over there, so it kind of connects with the original cut up on the roof and onto the other side. Okay, another thing that you might consider is that alignment. Try to consider alignment. That means that all of the cuts that you have done, from the top, it lines up against each other. If from the side, if it doesn't align there, it aligns from the top of this to the bottom of this. This one, yeah. So if it's not aligned all together, maybe it goes halfway into this area or something. All right, so try to explore that idea. So as long as you follow these requirements, you should be okay with that. Also, we have